So the question states that it's suggested that the following functions of v, f of v is equal to e to the power of minus mod v, f of v is sine squared v by v, and f of v is equal to 1 if mod v is less than or equal to alpha, 0 if mod v is greater than alpha. Minus alpha. So these functions may um, either represent an autocorrelation function of WSS by setting V is equal to tau, or may represent a spectral density function by setting V is equal to omega, or both. So the question is, which of the function or functions may represent either or both? Um, let R tau be the autocorrelation function of a real WSS process x of t. Then R tau is even and less than or equal to R of 0, and the Fourier transform of R tau is non-negative. If say let S of omega be the power spectrum of x of t, then S of omega is non-negative. So for the first one, it represents both an autocorrelation function and a power spectrum, because mm, uh, with respect to representing an autocorrelation function, it's because E of minus mod v is even, and E of minus mod v is less than or equal to E of minus mod 0, and E of minus mod v is equal to 2 alpha plus alpha squared plus omega square is non-negative. It also may represent a power spectrum because E of minus mod omega is greater than or equal to 0. For the second one, f of v is equal to sine squared v by v square. Uh, even it may represent both, because it may represent an autocorrelation function because sine square tau divided by tau square is even, and sine square tau by tau square is less than or equal to limit tau tending to 0 sine square tau by tau square is equal to 1, and sine square tau by tau square, which is this, and 1 is non-negative. It may also represent a power spectrum because sine square omega divided by omega square greater than or equal to 0. For the final one, it cannot represent uh, an autocorrelation function because its Fourier transform is not non-negative. It's a Fourier transform 2 sine alpha omega divided by omega. It's non-negative. It's not non-negative, and so it cannot represent an autocorrelation function. But it may represent a power spectrum because f of omega is greater than or equal to 0.